Grade 9 Mathematics, first quarter. Relation of roots and coefficients of a quadratic equation. Our learning competency: describe the relationship between the coefficients and the roots of a quadratic equation. Our objectives: solve for the sum of the roots of a quadratic equation. Solve for the product of the roots of a quadratic equation. The sum of the roots of a quadratic equation in terms of its coefficients is denoted by x sub 1 plus x sub 2 is equal to negative b over a. So to get the sum of the roots, we will use this formula, negative b over a. The product of the roots of a quadratic equation in terms of its coefficients is denoted by x sub 1 times x sub 2 equals c over a. Example number 1, without solving for the solutions of the quadratic equation for x squared plus 2x minus 5 equals 0, find the sum and product of its roots. So first, let us determine the value of a. That is equal to 4, since that is the coefficient of x squared. So a is equal to 4, while the value of your b is the coefficient of x, and that is 2. So b is equal to 2, and c is our constant, that is negative 5. So c is equal to negative 5. Now, we use our formula to solve for the sum and product of the roots. So again, to get the sum, we have negative b over a. We simply substitute. So b was replaced by 2 and a was replaced by 4. So that is negative 2 over 4. If we are going to rewrite this into its simplest form, this is equal to negative 1/2. Therefore, the sum is equal to negative 1/2. While for the product of the roots, we use our formula c over a. Again, by substitution, c will be replaced by negative 5 and a will be replaced by 4. So that is equal to negative 5 over 4. The fraction is already in its simplest form, so the answer is negative 5 over 4. Let us have another example. Without solving for the solutions of the quadratic equation 2x squared plus 8x minus 10 equals 0, find the sum and the product of its roots. Again, the formula for the product is c over a, and for the sum is negative b over a. But first, we determine the values of a, b, and c. Your a here is equal to 2. Your b is equal to 8, and c is equal to negative 10. Now we use the formula. Sum is equal to negative b over a by substitution. That would be negative 8 over 2. 8 can be divided by 2. 8 divided by 2 is equal to 4. Negative 4 is the sum of the roots. Now, for the product, again, that would be c over a. So, by substitution, that would become negative 10 over 2. Negative 10 divided by 2 is equal to negative 5. Therefore, our product is negative 5. Now, without solving for the solutions of the quadratic equation, x squared minus 2x plus 1 equals 0. Find the sum and product of its roots. So again, a here is equal to 1 since the coefficient of x squared is 1. Your b is equal to negative 2 and the value of c is equal to 1. Now, we use the formula. For the sum, we have negative b over a. Then by substitution, that would be negative 2 over 1. Negative 2 divided by 1 is negative 2. Preceded by a negative sign would become positive 2. Now, for the product, that would be c over a. We simply substitute c and a. So that would give you 1 over 1. And 1 divided by 1 is equal to 1. Therefore, the product is 1. On this example, we use the concept of the sum and product of roots to form the quadratic equation whose roots are 1 over 5 and 3 over 7. First, we get the sum of the roots. We add the two roots, 1 over 5 plus 3 over 7. So to simplify the process of adding the similar fractions, we multiply 5 and 3, and that would give us 15. 1 times 7 is 7. 5 times 7 is 35. Now, rewriting the equation, that would give you 7 plus 15 all over 35. And 7 plus 15 is equal to 22. Therefore, our answer is 22 over 35. This is the sum of the roots. How about the product? We multiply the two roots, 1 over 5 times 3 over 7. So we simply multiply numerators and denominators. So that would give you 1 times 3. That is 3. 5 times 7 is equal to 35. Therefore, the product of the roots is equal to 3 over 35. Remember that the sum of the roots is denoted by negative b over a, and the product is c over a. Hence, following the equation form, x squared plus b over a x plus c over a is equal to 0. We simply substitute our sum and product. So since this is denoted by negative b over a, when we substitute 22 over 35, that would become negative. So that would become x squared minus 22 over 35 plus 3 over 35. So to simplify, we are going to multiply both sides of the equation by 35. Okay, multiplying now, x squared times 35, that would be equal to x. And for this one, 35 divided by 35 is 1 times 22, that would be 22x. 35 divided 35 is 1 times 3 is 3. 0 times 35 is 0. Therefore, our equation is 35x squared minus 22x plus 3 equals 0. So that is our quadratic equation. Let us have another example. Using the concept of the sum and product of roots, form the quadratic equation whose roots are 5 and 12. So we follow the same procedure on example number 4. So we first get the sum of the roots. So this is easier because the numbers are whole numbers. 5 plus 12 is equal to 17. So that is the sum of the roots. The product of the roots is 5 times 12, and that is equal to 60. So again, the sum of the roots is denoted by negative b over a, and the product of the roots is denoted by c over a. Hence, following the equation form, x squared plus b over a x plus c over a is equal to 0, we simply substitute the sum, which is 17. So this will become negative 17 and 60. So that would give us x squared minus 17x plus 60 equals 0. So this now is the equation of the quadratic equation whose roots are 5 and 12. Now, you answer the activity, Module 7, what's more, page 6, what I can do, page 7. Once again, I am your math teacher, Sir Rainier M. Arellano. Keep safe, everyone.